Okay, good morning class.
Good morning, sir.
Let's go. Sorry about the delay in start. I don't need to save those things properly, okay. So let's go. At this point we're busy with graphs, not so?
Yes, sir.
Let me just open your textbook. It's grade 9. As a study and master. We are, which page are we on? No, we're still doing the, did I give you homework?
Yes.
Okay. So the homework was, oh yes, number 1. I cut that already. Let's check. Right, those were the lists I gave you on exercise on page 71. So just looking here for number 1. Say quick.
Hi, grade 9. If you paid for a pronoun badge already, if you ordered a pronoun badge, you need to pay by Monday if you haven't paid. And if you don't pay by Monday and you ordered, your order will be cancelled. And it's 10 rand. Thank you.
Okay, listen. So at this point we are looking at number 1. The standard form of a straight line is y equals mx plus c. It's supposed to have been equal sign. Okay, so y is equal to mx plus c. Is the standard form of a line graph, or straight line graph. The question says, what does m represent? M is your gradient. Not so. Another word for gradient is what? Slope. Or inclination. Okay. The incline, when you see somebody talk about the incline, is something that goes very slow. Okay.
Yes, sir.
The rise of a certain gradual value there. What does C represent? C represents the y-intercept, or where the graph cuts your y-axis. Okay? And lastly, 1.3, draw a graph where C is less than 0 and M is less than 0. People, what does C less than 0 mean? What does less than 0 mean? Negative, yes. Right, good. Whoever said that is negative. If you look at this number line here, less than 0. Can you see here? It's all negative numbers that are less than 0. Okay? All negative numbers are less than 0. And of course, if it says more than 0, those are your positive numbers. So if you look at where is m less than 0, m is negative. So this, if m is negative, what happens? The graph is increasing or decreasing? It's decreasing. So the graph has to go down. Right? Okay? And c is less than 0. What does that mean? So the cut below this axis here. Can you see that? So c has to be somewhere here, and there has to be a decrease of that. So that is your 1.3. Who got that right? Nice. You copied it from the book. No, then you didn't get it right. Then you copied it right.
But I didn't copy it. I only copied it. But then I said, right.
Right, let's look at 1.4. 1.4 says C is equal to 0. What does that mean? Your y-intercept is going to be 0. So we draw here. So it's going through the origin. Not so. However, m is greater than 0, which means to say your gradient is positive. The graph is increasing. So there we go. That's a graph. You're going to draw it. People, this one here, this graph here, can be anywhere as long as it's going in that direction, decreasing, and it's below, anywhere below on this y-axis. Can you see that? Doesn't have to look like halfway between, and anywhere here would be an acceptable solution on that question. Okay, who's next for the bathroom? Right, you next, then go. Did she ask before you? Okay, then you can go after. Okay. Any confusion here, people? Right, then I gave you a couple of the graphs to draw, not so? Let's pull that up quickly. The first one was, let's do the first column.
So you have to walk like a main road.
Yes. It's the same, listen. When we do the examples in the class, okay? And when I give you a homework, it's the same thing. I don't do examples in the class and homework you do something totally different. Okay. What do you say now?
She said that you
And I didn't know what's going on.
That means to say you didn't understand what properly happened in class and who were the examples in. Okay. Okay, so let's look at this here quickly. The first one I asked you was 2.1, 2.2, 2.3, 4, 5, 6. Alright, for that that's on the board is those ones. So 2.1, you got y-intercept. What do you do for y-intercept? That x equal to 0. So y is equal to 2 times 0 minus 2, which is negative 2. X-intercept. Let y equal to 0. So 0 is equal to 2x minus 2. Solve for x. Minus 2x is equal to minus 2, x equal to 1. So from here I can draw this graph. It's your y and your x. X is 1. Y is negative 2. Again, you take a ruler and you draw it through those points. Listen, you don't draw it through the number 1 and the number negative 2. No. You draw it where that is on your axis.
Yes, sir.
You guys understand?
Yes, sir.
Let's look at number 2.2. Any confusion here? No? To feel it, what's wrong? Right, let's go 2.2. You got y is equal to 2x plus 4. What was your y-intercept here? The y-intercept was? 4. 1, 2, 3, 4. And your x-intercept? Negative 2. You all agree with that?
Yes, sir.
There's your graph. Going through that quick. Okay, any confusion here?
No.
Let's look at 2.3. You got y equals x plus 5. What's your y-intercept here? What did you guys work out to 5? And your x-intercept? 5. 5 or minus 5? I also get negative 5 because, listen, listen, you guys are making a lot of noise in the background. Please stop it, no? I also getting negative 5. Just hang on. Your x-intercept, let y equal to 0. So 0 is equal to x plus 5. Take it over the equal sign, you get negative x equals 5. Now you divide both sides by negative 1. So x is negative 5. Okay? We use a ruler for those the separation bit. When you do this markings on the axis, please use a ruler for it. And there's your graph. For those of you who said positive 5, remember that this gradient is this gradient positive or negative? Positive, so the graph must be increasing. So if your graph was going that way, that would have been a decreasing graph. Does it make sense? Okay. So the one in black is correct. The next one I asked you to do is 2.4. You got y is equal to negative 3x plus 3. X-intercept, let y equal to 0. X-intercept is 1. What was your y-intercept? Huh? 3. So you're going to go through 1 and 3. So there's the graph. Okay? Let's go through this here. Ne? Okay. guys are making a noise here, ne? What's going on? Alright. Let's do 2.5. So you got y is equal to negative a third x plus 1. What's your y-intercept? No, minus 1. What's your y-intercept here? Sorry? Your y-intercept is negative 1. What's your x-intercept? Negative 3. You all got that, no? So the graph is going to come through like that. That is your negative 1, your negative 3. You all agree with that? It's 2.5. Yes? Nothing. Listen, if your graph is wrong, the sum is worth probably like 4 marks or 3 marks. Just to draw the graph. So you, on the graph we will give you the mark. Unless a question says work out your x-intercept, then you get the mark for that. But this is draw the graphs of each.
So you don't have to do.
You don't have to do the calculation now. You can do it in your head, it's fine, one side of it is fine. But we make it official, we make it part of your working out. But so that the examiner knows when this is maybe where you made a mistake. So it can make sense to you. You understand? It's going to be better for you to actually do the calculation on the side. Okay. 2.6. But the reason why I'm not working it out is because I want to go on to the next part. So your y-intercept for 2.6 for y is equal to negative a third x plus 2. It's 2 years. And your x-intercept? 6. If that is 2, 4, and that would be 6 here, not so? Yes. The graph will come through like that. Okay, and that is going through that point. 2.7. We've got to pull that thing down.
So you pass it. Is it so you pass it?
There's an example. Okay, so this is exercise on page. Exercise on page 71. Okay. One is correct. Okay. So I ask you to do number 12. Okay. So 2.12 follows the formula y is equal to negative half x plus 2. Not so? So what do we have? Your y-intercept is what? It worked out to be 2 years. And your x-intercept? 4. Okay? You're going to go through there and there. All agree with that?
Yes.
2.12, 2.14, y equals 4x minus 2. So what's your your y-intercept? Negative 2. And your y-intercept? Your x-intercept, sorry? 4. Half. This is 1, 2, then half will lie here, not so? It goes through like that. Whoops. The steep graph, no? There we go, that will be half. Alright, you all agree with that? You all know how I got a half. Who doesn't understand how we got a half here? You all okay with that? Yes? Nobody, okay. Then I asked you to 2.14. Is that correct? 2.14 y is equal to 4x minus 2. What's your y-intercept? What? No, we just did this one. $2.15. Whoever's talking in the background, just stop it please, man. If you don't mind. It's irritating. Okay, so what's your y-intercept here? 3. 1, 2, 3. And your x-intercept was? 1. Again, going through that point there and this point, your ruler line with a ruler. Okay. Don't forget to write your origin in there. 2.16 was the last one I gave it to you. No? Which is y is equal to negative 3x plus 5. Okay, that's not a very good representation there. Let's take this off. And what's your x-intercept? 5 over 3. Which is? 1 and 2/3. No? So if that is 1 and that is 2. 1 and 2/3 approximately here. Not so? So it's 5 over 3. It's going through that point there and that point. There we go. Alright, you all understand, people? Is there any confusion with regards to this homework? 2 million. I hope you're not chatting or anything on your phone. Don't put the book on top of your phone as if I didn't see it. What are you busy with? Girlfriend, I'm talking to you. What are you busy with? Chatting. Huh? What are you busy with? You were not busy with the graphs on your phone. Do I look stupid to you? Now why are you treating me as if I'm stupid? Okay. People, this is your own education that you guys are missing out. No? You're playing around. Alright, so at this point we have done a couple examples. Have we started on our next page yet? Just check. No, you're not in grade 10 yet, so I must add you. Huh? You're taking me for a fool. You like this one now? Huh? Please don't take me for a fool, no? If you don't mind. Especially when we're busy with a lesson. Alright, so at this point we have drawn the graphs in that form, okay, of y is equal to mx plus c. Now we're going to look at Unit 5. Right. I want you guys to write this down. You don't have to write the number 5 down. But you write the graphs of y is equal to A or x is equal to B. Write that down and you draw those two graphs for me. I'll explain it now. Let me just give you a chance to write that down. X equal to B. Then the line is parallel to which axis is the line parallel to? This line here, this line drawn in here. This is your y-axis and this is your x-axis. So it's parallel to your x-axis. You add that there. The line is parallel to the x-axis. It's part of the note there. Alright, so y is equal to a and x equal to b. We look at examples on page 67. In example 1, we asked you to draw the line y is equal to 3. So, we can't go y-intercept here because there's no x to let it equal to 0, not so. So what you notice here is that the graph of y is equal to 3 is actually the graph going through like that. Because let's take this number 1 into account here. What should this point here be? 1 and, what the coordinates of that point be? 1 and 3. If I take this point, which is 5, and I plot it here, what would that point now be? X is 5 and y is 3. Can you see that? If I take this point here, which is minus 2, what would that coordinate be here? Minus 2 and 3. So here we told that the line is parallel to the x-axis. What does parallel mean? It's equidistant at any given point. Okay, those lines are parallel. And hence they explain to you this here. It's exactly the same what I just did there. Then you are told, note that in the example above, every point on the line has a y coordinate of 3. This is a very important note right there. Note that. In the example above, every line and every point on the line is a y coordinate of 3. Okay, let's carry on. Now, if they ask you to draw the graph, x is equal to minus 2. You're asked now to draw the graph x equal to minus 2. So you see here, here's minus 2 on your x-axis, not so. You take a ruler, you draw a line going through like that. This line is parallel to what? To which axis? It's parallel to your y-axis. If I take this point into account, let's say that's 2 and 4 there. What will the coordinate of that point be? X is? Remember, a coordinate is always x then y. Not so. What's your x value here? Negative 2. And your y value? Not so. But if we take this point here into account, negative 2 and 4. We take 5 into account there. Negative 2 and 4. We take negative 1 here. Negative 2 and negative 1. Take negative 3 here. Well, what do you notice now? There's a consistent x value of negative 2. Or every point has an x value of negative 2. Here, note that in the above example, every point on the line has an x coordinate of negative 2. You write that note down there as well. Go for it. Why are you shouting so? Alright, you guys got it? So busy. Then we look at a couple of graphs of that nature before we move on. Okay. Alright, so just take us down here a bit. So let's look at the graph. I want you guys to sketch this graph. Y is equal to 2 and y is equal to negative 3. Sketch both graphs on the same system of axes, on the same Cartesian plane. Can you do that? So do the first one.
Yes, sir.
Here we go. That is going to be y and x. Y is equal to 2. So I draw the line. Not oh, it's a 2, no? You all agree with that?
So there should be parallel.
Yeah, it will be parallel to your y-axis. To the other point? The other equation, sorry, or the other line graph? The other one would be y is minus 3. It will be the line going through like that. You all agree with that? Going through this point at minus 3. No? Okay. See anybody that's confused? No. So, what if we had asked you to draw the graph x is equal to 1 and x is equal to minus 4? You draw it on the same system of axes. X is equal to 1 and x is equal to minus 4. So I'm going to do the first one. X is 1 there, not so? Take my ruler, go through 1. Okay? Which is this point here. Now you draw in the graph of x equal to minus. The same. You don't have time now to draw every time on your axis. Okay. Yes. Yes. You don't mind. So we draw. So -1, -2, -3, -4. You all agree with that? We'll come through like that. Okay. Then we'll go through that point of negative. People, you all are, who's confused? You all okay with this? Okay. Take this off. We'll leave it. So now we're going to look at graphs. So I want you to make that sub heading there. Graphs of ax plus by plus c using the intercept method as in 4. Don't have to say as in 4. Don't have to say 60. That you will get from your textbook if you need to know those numbers. Okay. I actually meant not to give you this graph. We're going to draw that graph quickly. Take this off. The graph of ax plus by equals c using the intercept method. Example, you got 2x
Your
plus
attention
2y
please,
equals
all
negative
girls
6.
performing at cultural evening to come to the hall for a practice that is straight after school. All girls performing at the cultural evening to come to the hall straight after school. And then we have a special announcement. Learners, please listen carefully. I have Mrs. Jackson here to make this announcement.
Good afternoon, everybody. Just on behalf of the grade 11 girls, we want to say thank you for the huge support that with everybody this today during first break, and also for the winner for the McDonald's prize with the person who dressed the best for Shakespeare Day goes to Amber Fisher in 10A.
Alright, so let's do this quickly before the bell rings. So we have 3x plus 2y equals negative 6. That's the form. Remember that when we worked it out, we worked out in the form of y equals mx plus c. It's a different format, okay? But it's the same calculations that we do as before. What do we do for y-intercept? The x equals 0. So 3 times 0 plus 2y equals negative 6. That gives you 0. So 2y is equal to negative 6 divided by 2. X is negative 3. Okay? So x is negative 3. Then you go y-intercept with x equal to 0. X-intercept with y equal to 0. So it's 3x plus 2 times 0 equals negative 6. That gives you 0. So 3x is equal to negative 6 divided by 3. X is negative 3. Whoops. This is a y. Okay, so that's my mistake there. So it's minus 1